All right, so now we're on to lesson 3 in Math 21 Outcome 9b, and we're going to talk a little bit about compound interest. So the first 2 lessons were on simple interest. This one is on compound. So it says Einstein allegedly claimed that the most powerful force in the universe is compound interest. Certainly, banks and other financial institutions use compound interest as a cornerstone for their success in the business of money making. How do they do this? In simple terms, they earn the difference between what they charge their customers to borrow money and what they pay in interest to investors. So what is compound interest? Compound interest is the interest that is earned or paid on both the principal and the accumulated interest. So what that means is if I put money into the bank and I get compound interest, whatever interest I earn in 1 year, I would actually earn interest on that interest the next year. So you're going to make more interest than you would with the simple interest that we did earlier. Compounded annually means it's going to get compounded once a year. However, there's many other types. There's different compounding periods. So for example, it could be annually once a year, semi-annually every 6 months, which is twice a year, quarterly, which is every 3 months, so 4 times a year, monthly, 12 times a year, weekly, 52 times a year, daily, 365 times a year. So again, when you have compound interest, you make interest on your interest. So on this graph, that's why the blue is above the red, right? The compound interest is above because you make interest on your interest. You make more money. So the first thing in this lesson that we need to talk about math-wise is the rule of 72. The rule of 72 is a simple formula for estimating the doubling time of an investment. What you do is you take 72 and you divide it by the annual interest rate as a percentage to estimate the doubling time. The rule of 72 is most accurate when the interest is compounded annually. So here's our first example. It says Chris invests $5,000 by purchasing a Canada Savings bond. The CSB earns him 9% compounded annually. Estimate the doubling time. So if I want to estimate, I use the rule of 72. So I go 72 divided by 9, and I get 8. So it's going to take roughly 8 years for his money to double. Now, interest rates are given per annum, but they can be paid out more than once a year. So again, remember, annually is once a year, semi-annually is 2 times a year, quarterly is 4 times a year, monthly 12 times a year, daily 365 times a year. And this is your formula for compound interest. A equals P, so A is the future value now, not the interest. P is the principal, same thing, how much money you put in. I is going to be the interest rate per compounding period. And we're going to learn a little bit more how to figure out I today. And then N is how many compounding periods it's invested for. And so what we're going to do is we're just going to get straight to an example so it'll make more sense. It says determine the value of I for each compounded interest rate. So to find I, what you do is you take your rate as a decimal and it's divided by how many times compounded per year. So the first one, it's 5% compounded monthly. So your I value would be, okay, 5 divided by 100 is 0.05. So I would go 0.05 divided by 12, because monthly is 12 times a year. So my I value would be 0.0042 if I round. Okay, 12%, change that 0.12. So now my I value is 0.12. Quarterly means 4 times a year. So my I value would be 0.03. C, again, you always want to change these to numbers that we can do math with by dividing by 100. So if I want to find this I value, I take the rate. And daily is 365 times a year. And if I divide that, it would round to be roughly 0.00016. 8% compounded annually, divided by 100, 0.08. So my I would be 0.08 divided by 1, because annually means once a year, and I get 0.08. So now you're just going to get a little bit of practice working with how to find I and the rule of 72. So that is practice 3